3.2 Covalent bonding. Non-metal atoms tend to receive electrons to fill the spaces in their outer shells. A covalent bond forms between a pair of non-metal atoms. The atoms share some of their outer electrons so that each atom has a stable noble gas arrangement. A covalent bond is therefore a pair of shared electrons. A small group of covalently bonded atoms is called a molecule. For example, chlorine exists as a gas that is made of molecules Cl2. Chlorine has 17 electrons and an electron arrangement 1s2, 2s2, 2p6, 3s2, 3p5. Two chlorine atoms make a chlorine molecule. The two atoms share one pair of electrons. Each atom now has a stable noble gas arrangement. The formula is Cl2. Molecules are neutral because no electrons have been transferred from one atom to another. You can represent one pair of shared electrons in a covalent bond by a line. Example, methane. Methane gas is a covalently bonding compound of carbon and hydrogen. Carbon, C, has 6 electrons with electron arrangement 1s2, 2s2, 2p2, and hydrogen, H, has just one electron 1s1. In order for carbon to attain a stable noble gas arrangement, there are 4 hydrogen atoms to every carbon atom. The formula of methane is CH4. The 4 2p electrons from carbon and the 1s1 electron from the 4 hydrogen atoms are shared. Atoms with covalent bonds are held together by the electrostatic attraction between the nuclei and the shared electrons. This takes place within the molecule. The simplest example is hydrogen. The hydrogen molecule consists of 2 protons held together by a pair of electrons. In a double bond, 4 electrons are shared. The 2 atoms in an oxygen molecule share 2 pairs of electrons so that the oxygen atoms have a double bond between them. You can represent the 2 pairs of shared electrons in a covalent bond by a double line. When you're drawing covalent bonding diagrams, you may leave out the inner main levels because the inner shells are not involved at all. The atoms within the molecules are strongly bonded with covalent bonds within the molecule. However, the molecules are not strongly attracted to each other. Substances composed of molecules are gases, liquids, or solids with low melting temperatures. This is because the strong covalent bonds are only between the atoms within the molecules. There is only weak attraction between the molecules, so the molecules do not need much energy to move apart from each other. They are poor conductors of electricity because the molecules are neutral overall. This means that there are no charged particles to carry the current. If they dissolve in water and remain as molecules, the solution do not conduct electricity. Again, this is because there are no charged particles. A single covalent bond consists of a pair of electrons shared between 2 atoms. In most covalent bonds, each atom provides one of the electrons. But in some bonds, one atom provides both the electrons. This is called coordinate bonding or dative covalent bonding. In a coordinate or dative covalent bond, the atoms that accept the electron pair is an atom that does not have a filled outer main level of electrons. The atom is electron deficient. The atom that is donating the electrons has a pair of electrons that is not being used in a bond called a lone pair. For example, ammonia, NH3, has a lone pair of electrons. In the ammonium ion, NH4+, The nitrogen uses its lone pair of electrons to form a covalent coordinate bond with an H plus ion, a bare proton with no electrons at all and therefore electron deficient. Coordinate covalent bonds are represented by an arrow. The arrow points towards the atom that is accepting the electron pair. However, this is only to show how the bond was made. The ammonium ion is completely symmetrical, and all the bonds have exactly the same strength and length. Coordinate bonds have exactly the same strength and length as ordinary covalent bonds within the same pair of atoms. The ammonium ion has covalently bonded atoms, but is a charged particle.